Welcome to The Explainer. Today, we're stepping right into a real-life backyard laboratory to decode a seriously fascinating botanical mystery. We're looking at a brilliant, grounded example of trial-and-error science. This comes directly to us from a gardening journal entry written by a super observant enthusiast named Ang, published back on June 10, 2026. In Notes on Gardening, Part 921, Ang documents what seems, at first glance anyway, like a totally mundane, everyday gardening task, potting seedlings. But this seemingly simple deep tray experiment ended up yielding some highly specific and totally unexpected results. So our goal today is to break down this experiment step by step to understand exactly what happened beneath the soil. We're going to look way past the dirt and the leaves to find the hidden architecture that literally dictates life and death in a backyard garden.
Okay, let's dive into this. Every good scientific inquiry starts with a problem, right? And our core question here is actually a really simple one. Why did the edge basil die? I mean, think about how totally perplexing this is for a gardener. You do everything right. You carefully measure out the water, you make sure the sunlight is hitting at just the right angle, you're checking the soil temperature, you do all the things that are supposed to guarantee a healthy plant. Well, Ang noticed that among the seedlings transplanted earlier, some mysteriously perished while others absolutely thrived under the exact same care regimen. They were watered the exact same amount, they were watched with the same attentive eye, and yet there was the stark, clear divide between life and death in this very specific batch of plants. It wasn't just a generalized failure, it was highly localized. So we are going to unpack the exact hidden environmental disruption that caused this sudden collapse.
All right, let's get into Section 1, the deep tray experiment. Now, in any garden, consistency is basically the holy grail. Gardeners obsess over variables. We meticulously track water schedules, sunlight exposure hours, and soil pH levels, kind of treating them like these complex chemical equations. But here, Ang introduced a main disruptive environmental variable that we honestly rarely think twice about, a taller than usual seedling tray. It is absolutely fascinating when you really pause and think about it. By changing just one single, seemingly insignificant piece of cheap plastic, specifically just increasing the vertical height and depth of the tray, Ang inadvertently created a drastically different microscopic environment for these young plants. It's such a powerful reminder that gardening isn't just a chemical process, It's a physical one. This simple shift in physical space, literally just the dimensions of the container holding the dirt, created dramatic, immediate, and totally irreversible results in the garden. Like, who knew that a couple of extra inches of plastic could act as a lethal variable? Moving on to Section 2, casualties and survivors. Now, what's really interesting about this next part is looking at the actual scene of the crime. Let's try to visualize the space within that deeper seedling tray so we can truly understand the aftermath. Ang's detailed notes give us this incredibly clear spatial layout. So imagine the tray sitting right in front of you. When we compare the edge placement versus the middle placement, a really stark, undeniable pattern emerges. The basil seedlings that were planted on the outer edges, they were the primary casualties. And they didn't just struggle, they completely failed to survive the transition to this new, deeper environment. They just withered away. But contrast that with the plant stationed in the center of the tray, which painted a totally different picture. The perimeter of the tray essentially became an absolute danger zone for these earlier transplants. It's almost as if this invisible boundary line was drawn within the soil itself, dictating that anything bordering the plastic walls was doomed to fail, while the center offered some kind of mysterious sanctuary. The exact data from Ang's observation maps this out perfectly. When we cross-reference the plant type with its placement and its ultimate status, the picture becomes incredibly clear. First, the edge basil died. But look at the peacock-flower. Regardless of being out there in that deeper tray, it survived. In fact, it seemed to grow really well. It was completely unfazed by the new depth. And then we have the anomaly, the absolute smoking gun that proves the rule. Exactly one singular basil plant, placed squarely in the middle of the tray, actually managed to survive. It's just a perfect little data set showing that both placement within the tray and the actual species of the plant played this intertwined role in who lived and who died. That one middle basil plant tells us that the tray itself wasn't toxic to basil, but something about the combination of being a basil plant and being on the edge in a deep tray was a fatal mix. Which brings us to Section 3, the root system factor. So the crucial point is, we have to pivot from these micro-observations in the tray to the macro-botanical rule governing all these outcomes. And that rule is root depth dynamics. And correctly deduce that the peacock-flower survived and grew well for a very specific anatomical reason. It naturally possesses a robust, vigorous root system that loves reaching downward. Those roots are perfectly suitable for growth at that increased depth. Basically, the roots in the deeper environment were a match made in heaven. The roots could stretch out, find water, and establish a really firm hold. The basil on the edges, however, possesses a completely different physiological makeup. Basil roots tend to spread outwards rather than plunging straight down. So they clearly lack the systemic ability to cope with that same vertical depth, especially when they were confined right up against the hard plastic edge of the tray where their natural lateral growth was completely restricted. And this brings us to a really profound yet incredibly simple truth about botany. Not all plant species are suitable for a seedling tray of such height. Let that sink in for a second. Think about the architectural implications of that. It isn't just about whether you remember to water them or if the sun was shining brightly enough. The physical architecture of the container dictates plant survival entirely based on the specific species you put inside it. Gardening is not just chemistry, it's structural engineering. Eng's insightful observation proves that you simply cannot force a plant to thrive in a depth its roots aren't biologically designed to handle. You can provide literally all the nutrients in the world, but if the physical space doesn't match the plant's anatomical blueprint, nature will hit a wall, in this case, quite literally the wall of a deep plastic tray. Let's move to Section 4, Lessons for Future Plantings, and see how this builds our knowledge for next time. This is what you should really take away from this explainer, straight from Eng's refined methodology. Step 1. Always observe survivability when you change an environment, even something as mundane as tray depth. Step 2. Acknowledge that root systems vary wildly. What works perfectly for a deep-diving peacock flower will absolutely not work for a shallow, spreading basil sprout. And Step 3, which Eng explicitly notes for the future, experiment with different plant species. This is how you take Eng's framework and apply it to your own life. When things die in your garden, it's not a failure, right? It's a vital data point. This trial and error data is exactly what guides a gardener to eventually match the perfect plant to the perfect tray. Embrace the mistakes, map the outcomes, and use those losses to architect a much more resilient garden next season. The entry ends simply. Till the next post. Yours truly, Eng. I just love that. It's a really charming, wonderful reminder of the true spirit of the hobbyist gardener. The backyard is not a sterile laboratory. It is a place of continuous learning, continuous observation, and sharing those minor but profoundly impactful victories and failures with the world. Eng didn't just throw away the dead basil and give up. No way. Eng documented it, analyzed it, and shared it so that we could all learn from that single, deep seedling tray. Which leaves us with this final thought. A simple change in the vertical depth of a cheap plastic tray wiped out an entire border of basil, but simultaneously allowed a peacock flower to completely thrive and flourish. So what hidden variables, what seemingly minor shifts in space, depth, placement, or physical architecture are lurking right now in your own backyard laboratory? Keep observing those details, keep analyzing your results, and never, ever stop experimenting. Thanks so much for joining me on this explainer, and I'll catch you next time.